igcse, physics, Edexcel, paper 1, fission and fusion. The diagram shows the main parts of a nuclear reactor. This is the diagram, and we have to match each part of the reactor with its function, with its main function. So the control rod is already done. It controls the rate of fusion. Control rod, this is the control rod. The coolant out, the coolant in, reactor vessel, shielding, fuel rods, control rods, fuel rods, moderator. Oh, and these are the matching options. Coolant, fuel rod, shielding, absorbs dangerous radiation, contains uranium for fission, and removes energy from the reactor. This is the answer. Coolant removes energy from the reactor, so it cools it, and the fuel rod contains uranium for fission, uranium as the fuel, and shielding, it absorbs dangerous radiation. So it's a shield and it doesn't let dangerous radiation get out. State the type of energy released in a fission reaction. It is kinetic energy. When the molecules and the particles move really fast, so they have a lot of kinetic energy stored in them. Explain the role of the moderator in a fission reaction. It slows neutrons and reduces kinetic energy Ke of the neutrons. And anyone from, so there are 2 marks, which allows fission to continue, which causes induced fission, and so neutrons can be absorbed by uranium. Explain in terms of neutrons what is meant by controlled nuclear fission. So in terms of neutrons, what is meant by controlled nuclear fission? Any 3 marks. So each fission of a nucleus caused by a single neutron. So a fission, the breaking of a nucleus, is caused by a single neutron. Each fission releases more than one neutron. Excess neutrons can speed up the reaction. More fissions release excess energy. Control rods absorb neutrons. Control rods regulate the rate of fission reaction. So the rate doesn't increase and reactor meltdown doesn't happen. So this is in terms of neutrons, what is meant by control. So controls is like it doesn't melt down, the reactor doesn't melt down and goes out of control. And we have to choose 3 from these. And fission releases more than one neutron, and excess neutrons can speed up the reaction. Fissions release excess energy. More fission, sorry. Yeah, so it's in brackets. They control rods absorb neutrons to stop it from going out of control. So they're called control rods. A student finds this representation of nuclear fission on a website. This is the daughter cell. So the daughter cell is the cell that is made, and uranium nucleus. A nucleus hits it, a neutron hits it, a daughter cell, not a cell, daughter nucleus, another daughter nucleus, and these are neutrons. Describe what happens when nuclear fission of uranium occurs. So, neutron absorbed by uranium nucleus. The nucleus splits, producing two daughter nuclei, and extra neutrons released. So, daughter nuclei formed, and extra neutrons are released. The daughter nuclei move off with high speed. Name the type of energy that this gives them. Kinetic energy. This diagram shows the main parts of a nuclear reactor. Uranium-235 nuclei undergo fission in a controlled chain reaction. So this is the shielding, and this is the rest of the diagram. This is the reactor vessel and all that. Describe nuclear fission and how the chain reaction is controlled. Use terms from the diagram to help you. So a description to include any five. Nucleus absorbs neutron, or nucleus hit by neutron. Okay, one mark. Or any five of these. Splits into two in brackets fragments, parts, or daughter atoms or daughter nuclei. Extra neutrons released. Kinetic energy release also with the neutrons, because the energy is stored in the neutrons, and released neutrons hit further nuclei. So those neutrons hit the other nuclei or uranium nuclei, and moderator slows down the neutrons, makes it more likely for a neutron to be absorbed. So if it's too fast, it may not be absorbed by the nuclei, I believe. More likely for a neutron to be absorbed. Control rods absorb extra neutrons. They absorb the extra neutrons, and yet that control rods help prevent a runaway or a chain reaction. A runaway chain reaction helps prevent a runaway chain reaction. So, like, it keeps going on, it's uncontrolled and all that. State the form of energy that is released during fission. As we saw earlier, it's kinetic or movement energy. And for the last one, how does the shielding improve safety? How does it improve safety? So, idea is that there's a radiation that comes off, so it absorbs the radiation slash particles slash energy. So it absorbs it, the shielding. As you can see over here, this is the shielding, it absorbs it. Thank you very much.